All right, everybody, what we're going to be talking about today are transformations. Again, transformations are things that we do to shapes or lines in geometry class. First off, what is a transformation? So a transformation can be one of four different kinds of transformations we're going to talk about in here, but mainly what it is it basically transform means to change. And in geometry, it means we're changing the position of a shape from one position to another. So it could also mean we are expanding the shape or shrinking it, but again, that would still change the position of all the points. So first off, we're going to talk about translations, also known as a slide. I like to think of it as, when you're translating a word from one to another, it means the same thing. It's just in a different place, like a different language. So that's what we're going to be talking about today, which is translations. You have reflections, which I think you know reflection in the mirror, so that's a common one. We also call that sometimes a flip, because we're flipping over the shape, and we're doing it across something, like across the x-axis, across the y-axis, across a line. It can be done a lot of different ways. A rotation, which is also known as a turn, and as you know, wheels rotate. Rotation means to turn. And the last one is a dilation. The first three, translation, reflection, and rotation, those ones, they maintain congruency because all we're doing is moving the thing, turning the thing, flipping the thing, but we don't change the shape and the size, which is, of course, the definition of congruent. Same shape, same size. For dilation, we actually do shrink or expand the figure. So it keeps the same shape, but not the same size. For example, when you look in a mirror, it is a reflection, so it's the same image as you, it's just been flipped around. An example of something that wouldn't be like one of these four things would be like one of those mirrors at the fun house at the fair or the carnival, because the whole point of that thing is to make parts of you look bigger than other parts, and so it looks strange. It looks not normal. It's not similar or congruent. For all of these, we're either going to keep congruency like the first three, or the last one will keep similarity, and that the shape will stay the same. So first of all, anytime we talk about transformations, meaning we take this shape and we move the shape over to another spot, whether it's rotated or flipped or whatever, we don't just give it three new letters. We don't just go D, E, F or whatever. And the reason for that is we want to make a note that this is that figure just translated to another place in a mapping, a one-to-one mapping. So it's gone from one place to the next place. So what we do is we use the same three letters, but we put this symbol on them that's called the prime symbol. It kind of looks like a 1, but it's not a 1. It's more like a tally mark. So like that. If I had a second transformation, another one that would done from the original, I might use two tally marks, like A double prime, A triple prime for 3, etc. And so you just put extra marks on the thing. And what that shows is that's where A went when we transformed it, that's where B went when we transformed it, that's where C went when we transformed it. Okay, what we're going to talk about today is translations. Okay, translations, remember, are slides going from one point to the next. So first of all, a translation moves the object a fixed distance in a given direction. It does not change size, shape, or direction it faces. So you're not going to have it turn, you're not going to have it flip over, you're just going to literally, it's like taking something on your table and sliding it with your hand without turning it, without rotating it. It's now in a new position, but it's facing the exact same way. Let's look at a specific example. Okay, and this is one's already in your notes. What we're going to do here is we're going to translate or slide 12 to x. So what that means is for every one of those 4 points you see and every point on the line that's not a labeled point, that whole thing is going to slide 12 to the right. Okay, and so it looks a little bit something like this. Okay, so as you can see, my -7 now is at 5. My -5 for t now is all the way over at +7. At s, I was at -4, and now I'm at 8. And for r, I was at -8, now I'm at -4. So everything is moved over 12 to the right. So a lot of people will ask, how do you do this? How do you easily do this? Well, there's a couple ways. First of all, you could write down the points, r, s, l, and t. Write them out as points. Okay? And then you could simply add 12 to all the x values, and then draw your new figure. That would work just fine. Second thing you could do is you could take each point, R, S, T, L, and just count 12 over to the right and plot the point. That would work fine too if you did that and then connected the dots. A third way, the way that I did it when I was a student, is to pick one point. Like for example, if I pick S here, I go 12 over to the right and I put my point. Okay, and then all I would do is to get R, I notice that I go 4 to the left and 2 up, like almost like make a little right triangle in my head. And then for maybe T, I'd go down 4, left 1, and then 2 to the left of that would be L. So I basically use one point as a point of reference and compare all the rest of them. There is no right or wrong way. Any way is correct as long as you understand that each piece has been moved the same amount. Even the points that aren't labeled, like the one right in between R and S, you can kind of see that crosses at a point there. That, if you notice, is also exactly 12 to the right. If any one of them didn't move the right amount, we would lose congruency, meaning they wouldn't be the same size and the same shape anymore. And probably what would happen is it would look weird. Something would look off. One of the things I do notice my students do sometimes is they do this too quickly and they'll count 11 over instead of 12 over for one of the points. And the shape's pretty close to the same, but it's not quite the same, so they maybe don't notice it. Unfortunately, that would be incorrect on a test or something. So what you want to do is maybe have more than one step. So count to make sure they're 12 over, but also kind of count, down to over 4 to get from R to S, and double check that those things still hold true as well. So the next thing I want to say is, how would this look? So I may say, hey, slide by adding 12 to X, or do a translation by adding 12 to X. However, you may also see sort of like this. I want you to do the translation, parentheses X plus 2, comma Y, parentheses. What that means is it says take X and add 12 to it, but leave Y alone. Okay, the next thing we're going to do is this is sort of like a two-step translation. You can go ahead and put both of them on your paper, but if I were to do this two-step translation, usually what you would do is have to go sort of from one to the next and then down to the third position. So in this case, I'm going to subtract 8 from Y, which means I'm going to take that thing and I'm going to move every one of those points down by 8. Seeing it one more time, I'm going to take each of those points. So I'm starting off at 7, and I'm going to move it down to -1 for R prime. So at this point, again, same thing. I could have just taken each of those points I just had and subtracted it. Now, this translation you see right now is actually the translation X plus 2, Y minus 8, because I did two things. I moved to the right 12, and I moved down 8. Some of you might be wondering, could I have moved down 8 first? Sure, think about it. If I move down 8 and then I move to the right 12, I'll be in the exact same position. So it doesn't matter which one you do first. You might want to be a little bit careful when we start getting into flips and stuff like that, whether or not that still is true. But for now, since all we're doing is just sliding twice, it doesn't matter the order. What I want you to pay attention to is, like we said, each point moves the same amount, which keeps the same shape for the figure. So why does this keep congruency? Because when you move every point at once, it doesn't change the shape, and it certainly doesn't change the size. Okay, so this is the first example. So it may already be on your notes, but if not, you need to plot the K, P, and E points on your paper. And we're going to do a few different things. Okay, the first thing I'm going to have you do is I'm going to have you list the coordinates of the points on your figure. So by that I mean the actual points. So if you want to pause the video while you do that, that works. Okay, so the 3 points are -5, -4, -9, -9, that's E, and -3, -8. Second thing we're going to do is we're going to do a translation. The translation here, okay, add 8 to X, and only X, and not do anything to Y. So when you do that, go ahead and draw that on your paper, label it K prime, E prime, P prime, and then hit play, and we'll see if you have the correct figure. All right, so what should have happened is you should have ended up with that figure right there. And you should have labeled it K prime, E prime, and P prime. So as you can see, I went from -9 on the E point to -1, etc. So now what I want you to do, the last thing, and you can pause it again, is list the coordinates of the points on KEP. All right, so what you have here is hopefully what you realize is all I did is basically add 8 to each of the X's. So the reason I had you do this is because you can see what we did is we actually drew the graph and then wrote down the points. But just as easily, I could have written down my new points just by simply adding 8 to each of the X's and then went ahead and plotted those points. So again, that's just another way to do it. Okay, we're going to try another one. So go ahead and pause this for a second. And as just like before, I'm going to have you go ahead and draw the figure on your paper and list the coordinates for each point. Okay, so if you did that correctly, your point should have been 6, 8, 9, 6, 6, 3, and 3, 6. So you can see because the E and the I and the T and the M are sort of diagonal, or sorry, straight up and down or left and right from each other, in that kite shape there, you get some of the same X's and Y's. This time, the translation I want you to do is I want you to subtract 5 from each of the Y values. So we're going to perform a slide that is X, Y minus 5 and label it T prime, I prime, M prime, E prime. All right. So you should have ended up with the figure right there, which is moving every shape down by 5. So from 8, I went to 3. From 6 for E, I went down to 1. And from I at 6, I went down to 1 as well. Just like before, I want you to go ahead and pause it if you haven't done it already and list out the coordinates for each of those points. Again, you should notice that you're just subtracting 5 from each of the Y's. All right, so hopefully you got this right. We subtract 5 from each of the Y's, 6, 3, 9, 1, 6, negative 2, and 3, 1. And hopefully you can verify that those points do in fact work on the graph. Okay, let's try another one. So here you can see we have what appears to be a right triangle. And I want you to go ahead first and draw the triangle and then list the points R, A, T as ordered pairs. Okay, so what we're going to do now, the points are 8, negative 3, 8, negative 8, and 4, negative 8. So now what we're going to do is we're going to perform a slide or a translation that has two parts. So we're going to subtract 7 from all of the X's and add 10 to all of the Y's. So go ahead and do that. Make your translation. When you feel like you're good and done, go ahead and hit play. All right, so if you did it correctly, you should end up here. And again, that is moving up 10 on the y-axis, so from negative 3 to positive 7. And then moving over 1, 2, 3, 4, 5, 6, 7. So again, to do this in 2 steps, meaning draw the triangle and draw it a second time, to me is the hardest way to do it. You could look at it almost like slope, where you go up 10, left 7. But I still feel like the easiest thing to do here is to simply figure out the coordinates of the r prime, a prime, and t prime by subtracting 7 and adding 10 and simply plotting your points on the paper. So go ahead and write those 3 points, verify that you did in fact subtract 7 from each of the x's, add 10 to each of the y's, and hit play when you're ready. Alright, so hopefully you noticed we went from 8 to 1, which is subtracting 7, and from negative 3 to 7, which is adding 10. So of course we did follow the pattern. Okay, last one for you guys to try. I don't know if you picked up on the animal theme, but here we have chimp, C-H-I-M-P. So what I want you guys to do is write the coordinates of those points, and then we'll do the translation. Okay, the points are negative 9, 6, 9, negative 8, negative 2, 7, negative 3, 3, and negative 8, 2. This time, we're going to subtract 1 from our x's and subtract 10 from our y's. And we're going to label C prime, H prime, I prime, M prime, P prime as our new figure. Okay, so hopefully you got it right. And it should be just like that. So as you can see, we moved down 10 and left 1 from our original position. Lastly, label my points. Hopefully you guys labeled the points now. C prime is negative 10, negative 4, and you can check the rest of your answers as well. So this is a quick activity. Remember that these are required for your notes to have this completely done, and there is going to be a form below that you can fill out. If you were in class today and you did all you were doing was finishing up the last few examples, you don't necessarily need to fill that out because I'll see your notes in class. But if you were absent, this is a great way to kind of make that up. And also, if in class today we didn't do these notes and this is a video homework, then you'll want to make sure you do that as well.